Welcome back. In the last session, we started the op amp and I explained the block diagram of op amp and I explained what is direct coupling, and we could do some coupling, or we could take out input capacitor and output capacitor by having dual power supply, and we could not remove the CE bypass capacitor. And how to remove that CE bypass capacitor from the configuration which is differential amplifier, that is what I am trying to explain. And I told that it is defined with two gains, number one common mode gain, number two differential gain. Common mode gain to be 0 means I don't want to amplify common mode signals, the signals which are common for both the inputs, that is what is common mode signal, including the bias voltage, noise voltage, right, and power supply or any coupling. We don't want to amplify the common mode signals because they are unwanted signals, and we want to amplify the differential signals because the wanted signals we will create them like differential wave, then we will try to give it to differential amplifier, then differential amplifier will amplify only differential signals, not common mode signals. That is what is our intention, right? The signals whatever we want to amplify, we have to create or we have to apply like a differential input, and that will be amplified. Whatever signals which are common for both the inputs V1 and V2, that will be rejected, which you want, which we want. Okay, that is what I am explaining. Now let's do DC analysis, only DC analysis, and then let's do only AC analysis. Okay, then we will understand. Write down the first one, DC analysis. Okay. Actually, I don't have space. I'm trying to use okay, the same circuit. What I do, you have to write DC analysis. Okay. Write down DC analysis. I'm going to explain only DC signals. DC analysis. Case 2 AC analysis. Okay. Now, listen. The signals whatever you want to amplify, let us say this is what is the common mode signal. I'm just defining it as common mode signal. And this is also common mode signal. When you say common mode signal, the signal which is common for both the inputs. Let us say V1 is equal to V2. Then you give AC signal, that is also common mode signal. It is not necessarily that DC voltage only common mode signal. The signal which is common for both the inputs, that is what is called common mode signal. And it will not amplify common mode signals. Why it will not amplify common mode signals? I will explain. Let us say this is what is my VCM, the common mode voltage or the bias voltage what you have at the input. Okay. Because this is 10 volts and this is 0 volt, let us say this is 5 volt. Okay. If this is 5 and this is minus 5, this is 0. The common mode voltage, what I am saying, this is 0. That itself is the bias voltage. 0, 0. That is what is common mode signal. But I am not speaking about dual power supply. I am speaking about single power supply. But I want to explain how we don't need the bypass capacitor. Now, tell me when input is VCM, can I say this is nothing but what? This is collector, base and emitter. Similarly, this is collector, base, emitter, right? Therefore, now tell me, this is VCM, this is what your DC voltage. Now, we are applying this DC voltage, this is with respect to what? Ground. This voltage is equal to VBE plus the voltage across the current source. Similarly, the voltage VCM is equal to VBE plus the voltage across current source. The voltage across current source, you can call this as emitter voltage, or you can call this as emitter voltage VE. We can call this as emitter voltage VE. VE is common for both the inputs, right? For both the transistors. Then whatever common mode voltage you are applying here, that voltage is equal to VBE1 plus VE. Then this common mode voltage or V2 is equal to VBE2 plus VE. For both VE is same, then if V1 is equal to V2 or V1 is equal to V2 is equal to V common mode, then VBE1 is equal to VBE2. Can I say that? Can I say that? That is what I am saying. Therefore, what I am saying, input KVL. If you apply input KVL, right? Now V1, what is V1? V1 is equal to VBE1. This is nothing but your VBE1. This is VBE1 and this is VBE2 for transistor 2. This is VBE2. Therefore, tell me what is that? V1 is equal to VBE1 plus VE, right? And what is V2? V2 is equal to, the voltage V2 is equal to VBE2 plus VE. VBE2 plus VE. And we know that V1 is equal to V2 is equal to VCM. I am applying same signal. That is what is your common mode signal basically. Whether it is a DC signal or AC signal, but whatever may be, if V1 is equal to V2, that is what is called common mode signal. Okay. Therefore, now when I say V1 is equal to V2, therefore V1 is equal to V2. For both VE same, therefore what does it mean? Therefore VBE1 is equal to VBE2. Therefore, when you say V1 is equal to V2, this implies that will give you VBE1 is equal to VBE2. When VBE1, that's what V1 is equal to V2 is equal to VCM. Let us say that is what your common mode signal. Okay. Therefore, VBE1 is equal to VBE2. When I say VBE1 is equal to VBE2, can I say your IB, whatever you have, let us say the same current will be flowing. Let me call this as, instead of IB1, IB2, let me call this as IB. Both will have same base current. Why? Both are having same VBE, but that VBE should be greater than or equal to 0.7, right? I am speaking about DC analysis. Therefore, same IB, that's why I am representing with capital letters, right? Now, same IB means, let us say both are identical. Both are identical. Both are identical means both are having same beta. When both are having same beta, then definitely both will have same collector current. Both will have same collector current, let us say IC, and this is also IC. When both are having same collector current, then both are same resistors, IC, then both will have same drop, IC into RC, then both will have same output voltage. Let me call this output voltage as V01, this is V01 and this is V02. Then both will have same output voltage. Then what is V01? Then V01 is equal to what? Out of VCC, the drop across RC, if you take it out, that is what your V01. Then if I write output KVL, this is output KVL, right? Then what is output KVL? V01 is equal to VCC, out of VCC, the drop if you take out, that is V01 with respect to ground. Therefore VCC minus IC into RC. Then what is V02? V02 is equal to VCC minus IC into RC. Both are same, right? Why? Both are having same IC current, both are having same RC, then both are having same drop, then V01 is equal to V02. Therefore V01 is equal to V02. Your output V01 is equal to V02. Therefore, when you take V01 is equal to V02, then what is the output differential voltage? V01 minus V02 is nothing but differential output voltage. Therefore, what is output voltage? Now your output voltage V0 is defined as either V01 minus V02 or V02 minus V01. Therefore, V01 difference to V02. Therefore, tell me what is V0 difference? 0. Therefore, your V0 is 0. If I define V0 as difference, because I am not taking V01, I am not taking V02, I am taking V01 minus V02, let us say, then V01 minus V02 is 0. But fine, that is fine. Now, therefore, if you ask me, both are having DC voltage. Therefore, both are having, this is also having DC voltage and this is also having same DC voltage. Let me say that is nothing but your output common mode voltage. I am speaking with respect to DC voltage. This is what is your common mode voltage. Both are having same. Right? Fine. Everybody understood the state of the circuit? This is what is the state of the circuit. Now, let me explain how it is rejecting common mode signals. How it is rejecting common mode signals. Now, let us say I'm increasing common mode voltage. Common mode voltage means I'm increasing both V1 and V2 at the same time. Therefore, your common mode voltage is increasing or common mode voltage is decreasing because same input. When you increase both of them at the same time, I don't want to see change in V01 and V02. I don't want to see change in V01. and I don't want to see change in V0 too, right? Because the common mode signal should not be amplified. Let's see. Let us say this is increasing. When I say this is increasing, this is also increasing. Let us say. Then let's see what's happening. Then this is increasing and this is also increasing. Can I say your VBE1 will increase? Let us say. When VBE1 is increasing, can I say your IB will increase? Let us say your IB is increasing by some delta 1. Your IB is increasing by some delta 1. Here also IB is also increasing by the same amount, delta 1, because I am applying the same input, change in input. Okay? Then if IB is increasing by delta 1, let us say your IC is also increasing by some value, let us say delta. Then how much is the increment in IB? Same, how much is the increment in IB here? That is what is giving some increment in IC. How much is the increment in IB? Because both are incremented the same way, the same increment you can expect here also, because both are identical, delta. Now tell me, here this is what is important point. Now tell me what is the current which is what is flowing through emitter. This is what your IE, right? This is what your IE, and similarly this is what your IE. Tell me what is this current. Instead of saying IE, therefore what is this current now? I can take IE approximately equal to IC. Therefore now tell me what is IC. Earlier this is what is IC, right? Therefore what is that IC? I bias by 2. It should be I bias by 2. Sorry, I forgot to explain. Before varying your common mode signal, this is IC, this is IC. You know what is that IC? I bias by 2, because this is I bias by 2. Why I bias by 2? Because this current plus this current is equal to I bias, and both are same current. Then definitely I bias by 2, I bias by 2. Therefore this is also I bias by 2. This is also I bias by 2. This is what is your current. Okay. This is having I bias by 2. When you add, we are getting I bias. Okay, this is what you are getting. This is what your I bias. This is nothing but I bias. Therefore, now tell me, if this is what is increasing by delta, IC is increasing. That is because of common mode. Therefore, common mode is increasing. Then IB is increasing. Then IC is increasing. Then your current is trying to increase. Let us say same current. Then delta. Then delta. Then what is this current? Then this current is nothing but what? But it is asking for what? It is asking for I bias, because this is what your current source. This is what is your current source. Violation of KCL. When you increase your input common mode voltage together, then both are increasing, then base current is increasing, collector current is increasing, then the currents, emitter currents, I bias by 2 plus I bias by 2 plus 2 delta. Therefore, I bias by 2 plus I bias by 2, I bias plus 2 delta, we are getting extra current. But the job of current source is to take always I bias only. That is what your ideal current source. That will not agree to take more than I bias. But your transistors are trying to give more and more current, because your input common mode voltage is increasing. I told you, right, wherever there is a violation of KCL, put a capacitor. That will explain. Wherever there is a violation of KCL, put a capacitor, it will explain. Therefore, let me put a capacitor. If I put a capacitor, therefore let me put a capacitor here. Just this is to explain or to get the answer. Okay. Then tell me, it is taking what? I bias by 2, I bias by 2. Out of I bias by 2 plus I bias by 2 plus 2 delta, I bias is going here. Then the 2 delta is entering into what? The 2 delta is entering into the capacitor. Then your capacitor. Before, if you don't vary your common mode, then your capacitor is charged to VE. But now, because extra current is flowing through the capacitor, then the voltage across the capacitor is increasing. Then your VE will increase. Then VE will increase. When VE is increasing, then what will happen? Your VBE will decrease. VBE will decrease. IB will decrease. IC will decrease. Then IC will come back to I bias by 2, I bias by 2. Done. Did you understand? I am repeating again. Therefore, when VE is increasing, now negative feedback, because the current source is acting as a negative feedback basically. Therefore, because current source is not agreeing to do not see or to do not see more than I bias, but we are getting more than I bias, because I bias by 2 plus I bias by 2, I bias plus 2 delta, the 2 delta now is extra going into the capacitor, because violation of KCL. Now your capacity is increasing, capacitor voltage is increasing, then VE is increasing. When VE is increasing, then your VBE will decrease. When VBE is decreasing, your IB will decrease. Whatever increment in delta, whatever increment in IB, now it will be decreased because of increase in VBE. Similarly, whatever increase in IB you have, then that will be decreased because of increase in VE. Then your IC, whatever increment you have, that will be decreased. Now if you ask me, your IB, it will become, right, this will be minus delta, because your VBE 1, whatever you have, right, your VBE1 earlier, now let me represent, therefore when this is increasing, your VBE1 is increasing, VBE1 is increasing, right. Now let me use a different color, black color only. Now negative feedback, that will decrease, then your delta 1 also will decrease, it will become minus delta 1, then minus delta 1, then it will become minus delta, then it is minus delta, then I bias by 2, whatever you have, it will become minus delta, and then it will become 0. Therefore it will become minus delta, I don't have space here, minus delta, then this 2 delta will become 0, then only I bias. That is what is our negative feedback. Therefore whatever you are having here, minus delta 1 here, then you will get minus delta 1. The black is representing negative feedback. See, I don't know if it is confusing you too much, right? That's why if you see here different colors are there, it is confusing, but I'll explain through sentence format, then you will understand, or I'll give you flow chart to explain. Okay, take it. Therefore ultimately what I want to say, ultimately very simple, when your common mode voltage is increasing, remember your emitter voltage also will increase, such that your VBE will be kept constant. If VBE is constant, IB will be constant, IC is constant, then output common mode is also constant, or output DC voltage is constant. You understand? Because when your common mode voltage is increasing, your emitter voltage is increasing. Then tell me, if base voltage is increasing, if emitter voltage is also increasing. If base voltage is decreasing, if emitter voltage is decreasing, then tell me what is your VBE? Your VBE is constant. If VBE is constant, IB is constant. If IB is constant, IC is constant. If IC is constant, your VOCM is constant. Even though you have variation in the input signal, there is no variation in the output signal. Therefore, there is no voltage gain for the common mode signal. Everybody understood? That is what we want basically. Therefore, we don't want to see any common mode signal change. And one more thing, not only this, because of VCM, due to temperature, whatever IC you have, right, both will increase or both will decrease. If both are increasing more than I bias by 2, current source will not agree, then this will change the VE, then it will try to decrease your IC also. Therefore, your Q point is also stable. If there is a change in IC, common effect, whatever common effect which is what is there for both Q1 and Q2, that will be rejected. Not only due to input common mode voltage, not only due to input noise signal, not only due to the noise which is what is there in IC. Noise means the temperature effect. If both ICs are increasing or both ICs are decreasing at the same time due to temperature, that also will be rejected, right? The common mode action will be rejected. That is what we need. That's why this is what is a differential amplifier. Who is rejecting? The current source which is what is there at the bottom, that is what is rejecting. Everybody understood? Take it. Then I'll give you the flow chart how to get it. Okay? Just a minute. You can continue. The blue is indicating the DC common mode voltage. The red is indicating if there is a change in the common mode voltage or the common mode effect, and the black is indicating the negative feedback that is correcting it. Therefore, ultimately your IC will not change. The common mode signals will be rejected. The same thing what I do, I can say under steady state, it's not under steady state, after all effects, okay, including negative feedback. Then if I draw this is I bias, and now this is what is our V1, this is V2, this is VCC, RC, RC, this is V01, V02. Right? Now if you ask me, this is what is your common mode signal, this is VCM and this is VCM, right? Then whatever, this is nothing but your I bias by 2, and this is also I bias by 2, and this is what is emitter voltage VE, okay, and this is nothing but your collector current IC, this is also collector current IC, right? Now due to any reason, if your common mode voltage or if there is any common mode signal change, but remember the emitter voltage will be adjusted to make VBE constant, okay. This is nothing but your emitter voltage will be adjusted, but your collector voltage will not change, then your output common mode voltage also will not change, your output voltage will not change. The change in output voltage is 0. Therefore, if I explain the same thing using flow chart, right, due to any reason, okay, I am explaining, okay, if VCM increases, okay, then what is happening, your VBE1 or VBE2, VBE1 or VBE2, right, increases, then your IB increases. When IB is increasing, right, then indirectly that is what is saying your IC is increasing. When IC is increasing, okay, therefore this is what is your common mode effect. What I do, I will rub it and then I will explain that. This is not enough, the space is not enough. Okay, what I have explained. Is this over? Okay, I'll give you 2 more minutes. You try to draw. If you don't draw, even if it is clumsy, let it be. But while writing, you will understand how to write and all. But ultimately, that is what, including negative feedback, your VBE will be kept constant. That is what I want to say here. Therefore, your VBE, this is what your VBE. Your VBE, right? Here also the VBE, this is VBE1 and then VBE2, right? That will be constant. Therefore VBE1 is equal to VBE2 is constant. Even though you are having the common mode voltage variation, that won't change. Ultimately your VBE will be constant for common mode signals, input common mode. But if you see the IC variation, then your VBE will decrease to make IC compensation. That is a different one. This is with respect to input common mode signal. Similarly, for your DC collector current change, because both are increasing, then your IC into RC is increasing. Whatever may be the operating point is changed. Operating point is nothing but IC and then VOCM. Therefore, operating point should not be changed. If the same current is flowing, VE will increase. Even though your VCM is constant, then VE will increase, then VBE will decrease, IB will decrease, IC will decrease. Due to any reason, if IC is also increasing, then the VE is the one which is what is trying to do something such that your IC is constant. Ultimately, the job of the current source is to maintain the current through this I bias to by 2, I bias by 2. That's it. Whether the change in IC due to input common mode or the change in IC due to temperature, whatever it may be. Okay. I'll give you 30 more seconds. Now if you ask me, the Q point stability factor is 0. It will not allow the change in IC at all because of ideal current source. But practically, do we have ideal current source? No, practical current source. Therefore, there will be small variation. The Q point will be changing little bit, but it is almost stable. Okay, but this is which is ideal scenario. Can I erase this? Let me explain through flow chart. Just listen. I'm explaining, right? Let us say, okay. Now, let us say VCM is increasing. Then what will happen? Your VBE1 or VBE2, right? Increases. VBE1 or VBE2 increases. Then what about your IB? both IB1 and IB2. Therefore, that is nothing but IB. IB increases. When IB is increasing, what about your IC? Increases. Therefore, there is a change in IC. Whenever there is a change in IC, current source will not agree. How? That's what I'll explain. Therefore, IC increment is due to now common mode voltage. Not only that, there is another thing. What is that? If temperature increases, I'm explaining all together. We know, right? IC not increases. That is another Q point stability. Then your IB increases due to temperature, and your beta increases. All three together increase your IC. If IC is increasing either because of temperature or because of common mode signal or because of anything else, due to any reason, if IC is increasing in both the cases, let us say, right, when both are increasing at the same time, I'm speaking about only common mode effect. The temperature is also common mode effect for both, right, for both the branches. Common mode voltage, the signal which is common for both the input, that is also common mode, right? The common mode effect, which is what is affecting your IC, then immediately what will happen? When IC is increasing, what will happen? Your IE will increase, right? Your IE will increase. Therefore, your IE, which is nothing but I bias by 2, right, increases. When that is what is increasing, then what will happen? If that is what is increasing, more than I bias by 2, then your VE will increase. Then your VE will increase. Then when VE is increasing, what about your VBE? VBE is equal for both. It is happening for both. VB minus VE. Your VBE decreases. When VB is decreasing, then your IB will decrease. When IB is decreasing, then your IC will decrease. Due to any reason, if there is a change in IC, due to any reason, change in IC means common mode IC, means IC which is common for both. If there is a change in IC, increase or decrease, this will not agree, then the VE will be adjusted automatically to get IC is equal to I bias by 2 always. Therefore, this is what is, now if you ask me, absolutely constant, not approximately constant. In this architecture, your IC is absolutely constant. Your Q point is absolutely stable. Q point is absolutely stable. Take this flow chart. Okay? This is again sequential explanation. But practically, remember, if there is any change in IC due to any reason, then immediately VE will be tracked because of current source, then it will not agree to see the change in IE. Okay? That will come into picture immediately. But this is what is our sequential explanation. The common action whatever you have between these two branches, the current source will not agree for the common action or common changes. It will agree for differential changes. That is what is our differential gain which we want, because that is what is the gain which we need for signal amplification. Then we have to create differential signals for signals, not common mode signals. If you give same signal whatever you want to amplify, that is nothing but a common mode signal. The signal which is common for both the inputs, immediately it will reject. We have to create like a differential manner, then we have to amplify through differential amplifier. That's why your op amp is associated with, remember, because the first stage is differential amplifier, your op amp will amplify only V1 minus V2, that is nothing but VD. It will not amplify common mode signals. If you apply V1 is equal to V2, it will not amplify, it will give you 0. Because V1 minus V2 is 0, VD is 0, V0 is equal to AD into VD, VD is 0, then V0 is equal to 0. It will not amplify common mode signals, it will amplify only differential signals. Because it will reject the common mode effect, either with respect to input V1 and V2 or with respect to the temperature phenomena which I explained, either IC change or input voltage change which is common, or due to any noise. The noise which is common for both the input, that also will be rejected, which we need, noise rejection. I'll give you 1 more minute time, then after that I'll explain what is common mode gain. For this the common mode gain is 0, but I'll define what is common mode gain. Then this is what is going to give you common mode gain 0 because of ideal current source. But later on I am going to derive, not now, after completing AC analysis, then how is it doing differential amplification, differential signal amplification, then that part I'll explain during AC analysis. Then I'll explain with respect to practical current bias what is common mode gain. But further we should know the common mode gain definition. I'll give you what is common mode gain definition, but here it is 0. Now common mode gain definition. Common mode gain, default voltage gain, that is what people call it as ACM, common mode gain. Okay, it is defined as, just listen here, I'll give you time to write down. It is defined as, it is not V01 minus V02 divided by V1 minus V2, that is differential gain. Common mode gain is defined as what is change in V01 because of change in common mode voltage. Therefore, what is change in output voltage V01 because of input common mode voltage VCM, or because we have two outputs, right? Change in V02 due to common mode voltage change. Therefore, what is delta VCM? Delta VCM is nothing but the common mode signal. V1 is equal to V2. Okay. Therefore, what is the change? What is the change? Maybe therefore, this is nothing but either V1 or V2, delta V1 or delta V2. Okay. This is what is your common mode gain. Therefore, tell me in this example, what is the change in output voltage? Even though your input common mode voltage is changing, what is the change in the output common mode voltage? There is no change. Therefore, what is this? This is 0. Your common mode gain is 0, ideally. And that is true because of ideal current source. If you want delta V01 divided by delta V1. But if you say delta V1, you may say V2 can be anything. But that's why VCM is nothing but V1 plus V2 by 2, or V1 is equal to V2 is equal to VCM. Okay. If you ask me what is VCM, where VCM is equal to V1 plus V2 by 2, or I can say in this example V1 is equal to V2 is equal to VCM. Therefore, V1 is equal to V2 is equal to VCM. When both are shorted, then when you vary the common mode voltage, what is the change in either V01 or change in V02? We are expecting that to have zero change. Therefore, common mode gain is equal to 0. Yes, we want common mode gain is equal to 0. Therefore, common mode signal rejection. Either noise signal rejection or due to temperature, the collector current rejection, whatever it may be. Or due to some coupling, some crosstalk, whatever which is common, or whatever power supply variation, everything will be, whatever common for both the branches will be rejected. That is what a measure, the common mode gain is the measure of common mode rejection. That is what is defined as common mode gain. We want common mode gain to be 0. Remember, not very high, because it is a gain. Don't think that it is a gain. It is common mode gain, it should be 0. Repeating again and again, because it has to go into your brain. Over. If this is over, then write down AC analysis. This is differential amplifier DC analysis, right? Now write down AC analysis. Can I erase all these things? Okay, AC analysis. You have to draw once again, but I can use it. Okay. I will also draw once again. If the bottom current source is ideal, then your common mode gain is 0. If that is not ideal, it will not give you common mode gain 0. That I will prove, or that I will derive in the next session. First of all, let's complete DC analysis and then AC analysis with current source. Then we will see again DC analysis, AC analysis with practical current source, because there are problems associated to the practical differential amplifier. Now, if you speak about AC analysis, only AC analysis means gain, the AC signal amplification. Now, if you see here, this is I bias, right? This is V1, V2, V01, V02, RC, RC, and this is VCC. Okay. Now transistor 1, transistor 2. Now listen. Before applying your AC signal, right? We should have DC signal. That is what your common mode signal. That is what your bias voltage. Therefore, this is what your DC signal. Then we already studied, right? Then we have IC. IC is equal to IE, which is I bias by 2. Then this is nothing but IE, which is nothing but I bias by 2. Here also I bias by 2, because this is I bias, and this is your emitter voltage VE. Okay, and then we have output DC voltage. Therefore, this is what is your output DC voltage for both VO, CM. Okay. Now, let me apply the signal whatever I want to amplify. The signal whatever I want to amplify, I'll apply in a differential manner, not in the same. If I apply the same sine wave here also, remember that will become common mode signal, because same signal we are applying. If you apply same signal, it will reject. That is what we had seen, common mode signal rejection. Now we are applying in opposite way. Opposite way in the sense differential way. Differential way in the sense when input is increasing, when V1 is increasing, your V2 will decrease. That is what is your on top of DC signal. The DC signal is bias voltage, which is common. The bias voltage is constant. But now the signal whatever you want to amplify, apply like this, differential manner. Then it will accept. If you apply like this, it will not accept. Okay. Now see here. Now I can explain. V1 is increasing. VBE1 will increase. Then what about your IB? Let us say this is what your IB, this is your IB, and here also we have IB, the base current, right? This is what is IB. Now when input is increasing, when V1 is increasing, then your IB will increase. Let us say your IB is increasing by small IB. Then here input is increasing, therefore IB is increasing. Here input is decreasing, your IB will decrease. Let us say it is decreasing by IB. But remember, how much is the increment in voltage? Same amount of voltage is decreased, that is nothing but differentially applied. Then how much is the increment in IB? Same amount of IB is decreased. How much is the increase in IB, and then how much is the decrease in IB? Then let us say your IC is also increasing by something, let us say delta. Then how much is the increase in IC? The same amount of IC will be decreased here because your IB is decreasing. Then what is this current? I bias by 2 plus delta. Then what is this current? I bias by 2 minus delta. Then what is the total current? I bias by 2 plus I bias by 2. I bias. But what is the current? Delta minus delta will be cancelled. I bias. Therefore, it is accepting until unless the total current, which is what is flowing through I bias, right, is I bias, it will accept. It is accepting. There is nothing, no change. Why there is no change? Your emitter voltage is constant. Why emitter voltage is constant? Your emitter voltage is constant. Why emitter voltage is constant? Remember, when this is increasing, this will increase. When this is decreasing, this will decrease. When both are changing like this, the change in VBE, VE is constant. There is no change in VE. If there is no change in VE, when this is increasing, effectively VBE is increasing, right? When this is decreasing, effectively VBE is decreasing. Then effectively IB is increasing, IB is decreasing, IC is increasing, IC is decreasing, drop across RC is increasing, drop across RC is decreasing. Then corresponding to your input, you will get the output something like this. Now I can say when VE is constant, then people call this as, the VE is called as AC ground. For AC analysis, if there is any constant value, how will you represent? I already told you, right? Because delta VE is equal to 0. Then this is what is connected to ground. Then it is simply common emitter amplifier. When this is connected to AC ground, it is common emitter amplifier. This is also connected to AC ground, common emitter amplifier. We are getting gain. Therefore, it is same as our common emitter amplifier. There is no change. Therefore, the current source is not coming into picture for differential signals, but the current source will come into picture for common mode signals. If I see changing exactly in opposite way, that opposite way will happen only because of the signals. That opposite way will not happen for due to temperature or due to common mode variation. I hope everybody understood. Okay. Now draw the circuit. I'll stop now. We have only 1 minute or 1.5 minutes to close the session. Then I will continue in the next session. Next session, right? This is what I will prove, that the differential amplifier voltage gain is same as single-ended common emitter amplifier which we derived. Both are same. Then we will go for practical differential amplifier with a practical current source or resistor. Then we will see what is common mode gain and what is differential gain. Then I will define what is common mode rejection ratio. Okay. If you want, you can pause the video and then draw this. Else we have 1 minute time. Then we can see that. Okay. Try to pause the video and then draw it. Then remaining 3 part that I will explain in the next session. Thank you.